Good morning, everyone. Welcome. My name is Partridge, and I work on the Kitura framework. I'm joined by my colleague, David Okun, who's a developer advocate at IBM. Today, we're going to get hands-on with Kitura, and David is going to show you how you can build a social network in Swift. But first, I'm going to talk briefly about two of the key use cases we see for server-side Swift and the cloud technologies that successful apps are being built on today. I also want to mention some of the exciting new developments that have happened in the Swift ecosystem recently. The first key use case for Swift on the server is mobile backends. Nowadays, no app lives in isolation, and your app might use a variety of remote services. As an app developer, you make choices about which backend technologies you're going to use. You could use only individual third-party services. So which services you use would depend on your app, but you could use location services, weather, or more. You could choose a fully hosted service, a so-called mobile backend as a service, or MBAS. These give you a broad range of functionalities, but you lose some control of your backend to the service provider, and they can be an expensive option. Another option is to build the backend yourself. Languages like PHP and Ruby have historically been popular, but they may mean learning a whole new set of skills. Server-side Swift is another option you have for your mobile backend. If your backend is written in Swift, it can be owned by your iOS team, and it can evolve to serve the unique requirements of your app. You don't have to wait for a separate backend team to implement the requirements you have. Plus, you get to build your full-stack skills and broaden your experience as a developer. The second use case we see for server-side Swift is microservices. Many companies today are evolving from large backends built on Java or PHP to smaller microservices. You can think of a microservice as an app which does one thing and does it really well. Swift is a great fit for the cloud microservices because of its core characteristics. Firstly, Swift starts up fast because your app is a compiled binary. It starts in milliseconds, which means it's easy to scale in the cloud, and you can quickly add more instances when you need them. Secondly, Swift has low memory usage. Swift microservices tend to use less memory than languages like Java, and their performance can be more predictable. When you're deployed in the cloud, you often pay by how much memory you're using, so having low memory usage can give big cost savings. And thirdly, Swift has excellent interoperability with C and more. With the delivery of the dynamic member lookup feature in Swift 4.2 and dynamic callable in Swift 5, you can even call out to dynamic languages like Python. For an example of this, I'd like to mention Allegro. They are an e-commerce company in Poland. They gave a great presentation at the Server-Side Swift conference in Berlin last year, where they talked about a microservice they have in production. They made significant savings to their data center costs by rewriting a Java microservice in Swift. And if you'd like to see their full presentation, it's on YouTube through the short link you can see. So we believe server-side Swift has some unique benefits you should consider, and that Swift can help you build your career and become a full-stack developer. But in order to be successful, you don't just need to write your app, you also need to deploy it and run it in production. And that's where we find people have questions. So in recent years, there's been a lot of new cloud technologies. It can be hard to know what to choose. We want to make it really easy to deploy your app. When you create a new app, we create the configuration files you need for building a Docker image and a Helm chart, which makes deploying your app to Kubernetes easy. Kubernetes is the most popular way to run Docker containers in production. Our metrics solution integrates with Prometheus, so you can monitor your application's memory and CPU usage, and you can graph the metrics using Grafana. And Kitura includes built-in support for OpenAPI, which automatically documents your API for you. Let's take a bit of a deeper look at what OpenAPI is and what it can do for you. So as an iOS engineer, you're used to dealing with remote APIs. Some of them might be easy to use, and some might be difficult. My colleague David is going to give a demo of OpenAPI in a minute, but in summary, it's an open standard for documenting REST APIs. It allows you to describe your entire API. Let's look at a quick example. Here's part of an OpenAPI document automatically generated by Kitura. This extract describes a path on /users, which consumes and produces JSON. On success, it responds with HTTP code 200 and a user object. Kitura will generate this document for you so that you don't have to write it. The power of OpenAPI comes because it has an ecosystem around it, with support for creating and testing OpenAPI documents, along with code generators for creating client SDKs. So you can easily talk to an OpenAPI server from iOS, Android, and much more. You'll see this in just a minute. But it's not enough to just have some cool technology. Swift needs a broad ecosystem. And over the last year, big progress has been made on that. Yesterday, Tom Doran from Apple told us all about the Swift Server Working Group. It's delivering code which will help interoperability between server-side Swift packages, plus, of course, the Swift Neo networking framework. Releases of Swift on Linux are happening much faster than before. Swift 4.2.3 for Linux was released yesterday, with many bugs in Foundation fixed, and Swift 4.2.4 for Linux is coming soon. Now's a great time to contribute to Foundation on Linux, because your code will be released much quicker. The release of the new language server protocol for Swift is a big step forward for Swift IDEs, as we heard in a lightning talk yesterday. It means Swift can be a first-class citizen in VS Code and many other popular editors, and David's going to show this in action in just a minute. And finally, there's been much improved platform support. Swift on Windows is making enormous progress, and IBM has also released a port of Swift to the mainframe. So we've just discussed some open source technology and a maturing ecosystem which you can use to build and deploy server-side Swift apps. To help you become a full-stack engineer, we've recently partnered with Ray Wenderlich to release a book which explains all these technologies in detail. The book takes you through building a complete Kitura application, including REST APIs with OpenAPI, a web front end, and an iOS app. The idea used through the book is Emoji Journal, a social network in Swift. It's really great to be here in Japan, the home of emoji, to show it to you. And here's David to see how it all works.
Hello, everybody. I'm David Okun, and I co-wrote server-side Swift with Kitura, with Chris Bailey. And I want to make sure Ian gets credit for this. He actually came up with the idea for Emoji Journal, and we made it happen. So it's a social network written in Swift, and it's the sample project that you work through in the book throughout each chapter. It's very focused on your feelings. So without any further ado, let's dive right into Emoji Journal with a live demo. So first things first is we're just going to go ahead and open up Xcode so that we can start working on our mobile application. You know what though? We covered this earlier. We actually don't need Xcode to run any of this, or even the iOS app. So we're going to go ahead and use the command line to run our iOS application. If you've ever used Jenkins to run tests on the iOS simulator on a Mac Mini or anything similar, this might not seem like sorcery, but it is still pretty cool to not need Xcode to get your app built and running. Don't you wish all of your iOS app builds went this fast? So using the command line, and our iOS simulator, we'll go ahead and run our application on the simulator. Now let's go ahead and use Visual Studio Code to open up our server. Thanks to the power of the language server protocol, as you saw yesterday from Rio, and its hook into SourceKit, we can use Visual Studio Code to open up our server code, check to see if we have any issues, and run the server on our machine right away. Notice how quickly the Swift LSP is able to show me information about any different objects that I have. This is one of the benefits of working with the LSP, aside from just being in an IDE that isn't Xcode. Okay, now let's go to localhost port 8080 to check if we're up and running. We sure are. Now let's take a look at how we've organized our server. As Ian mentioned earlier, Kitura provides a module that converts the routes on our HTTP server to an open API specification. And from that specification, we have a handy page that gives us the ability to easily and instantly see what routes we have to work with in a visual and easy to understand manner. Let's see how this looks when we add a new HTTP route. I'm going to add a new GET route that simply gives us a hard-coded journal entry. We can also bypass authentication here, but only for just a brief moment. We'll get back to that in a minute. I'm going to hard code a route to get one journal entry. So my completion handler will give me either a journal entry or an error. And notice again in Visual Studio Code how autocomplete is working for me. Just like before, let's go ahead and rebuild our server now with the integrated terminal in Visual Studio Code. Looks like we're in good shape, so let's go ahead and run our server. And let's go see how that looks in our OpenAPI UI. Just by writing that route, we've generated and documented a new route. And if we test it, great. We can see that that worked just like it should have. And that was generated for me on the spot. Okay, now let's try to get all of my existing journal entries. Now, as you can see, our Emoji Journal network is extremely secure, so we need to log in with our very secure and secret password, 123455. I hope nobody uses this password on anything they own, such as their luggage. Now that I've authenticated myself with type-safe middleware, I can take a look at all the journal entry objects that I've associated with my username. This looks great and gives me an easy way to iterate and debug my server as I write code for it. Let's go ahead and look at what that middleware looks like. All I had to do was stand this up and associate it with the proper routes. Now, watch what happens if I modify my earlier hard-coded route to use user authentication. All I have to do is add the user auth parameter into a route. I'll rebuild my server and rerun it one more time. And as you can see here, if I try it now, our hard-coded route is now protected by user authentication. And all we had to do was add the parameter to the route, and Kitura takes care of the rest for you. Now, because this is a social network, we really want to maximize brand awareness through cross-platform engagement. So let's spin up our web client. Sorry, that sentence always makes me a little nauseous to say. Let's try to add a new entry here. Notice the iOS app here. As soon as I add a new entry, the iOS app is going to automatically update. I'll explain why after it does, but don't blink because you'll miss it. I'll use my emoji picture, and it uploads right away for me on the iOS app. We didn't get to talk about this much in the book, but for this demo, we've hooked up the mobile app to work with WebSocket technology. WebSockets are full duplex, which means that both ends of a connection can send and receive messages to one another. This means that messages can be turned into commands on any client that you want. Because this is full duplex, this means that you can have the web client do work in response to a message as well. So I'll use my iOS app to add in a new emoji. And my web client updates right away. So sweet. Now everyone is up to date with how we're feeling. And I think this is a very fun project to work through, and we're constantly thinking about ways to improve it and help readers learn more about server-side Swift. And now you've seen how to write a full-stack social network in Swift. Now I'll turn back to Ian to wrap things up. Thank you.
Thanks, David. That was really great. Now, one of the most common questions we get asked about server-side Swift is, but is it really ready for production? So to end our talk today, I'd like to talk briefly about 3 case studies of applications that are in production. The first is online Swift playground.run. I'm sure you're all familiar with Xcode playgrounds. They provide a really quick and fun way to experiment with Swift and share your code. Online Swift playground.run is a playground in your web browser built on Kitura. The site was created by the independent developer Marcin Krzyzanowski, and it uses a Kitura cluster running on Kubernetes. You can try it out today. It's great for experimenting with Swift when you don't have Xcode handy. The second case study I'd like to mention is Agenda. So Agenda is an amazing notes application for macOS written in Swift. It has a unique approach of organizing notes into a timeline, and it synchronizes your notes across devices using iCloud. At WWDC 2018, Agenda won an Apple Design Award. Where does Kitura come in? Well, Agenda uses a freemium revenue model. The core app is free, but you can pay to unlock premium features. The Agenda team use Kitura for their licensing server. Kitura tracks user accounts and in-app purchases. Agenda queries Kitura for the user's license status to check which features should be unlocked. And Kitura is deployed to the cloud, this time on Heroku. The final production story I want to share today comes from a bank in the Netherlands, ING. They're using server-side Swift in a really cool way to reinvent banking for the Internet of Things. The idea all came out of a hackathon, and it's grown to become a new platform for developers, all built on Swift. The core problem that Banking of Things aims to solve is, how can IoT devices make secure, smart payments? For example, a smart light bulb paying for its usage per minute, or a smart water filter ordering itself a replacement when it needs to. You can learn more about Banking of Things and sign up for a developer account at their website. And they've been in production since last year. I'd like to show you a little bit about how it works. So the core of the platform is a REST API written in Kitura using the codable routing features David just showed you. This implements the core business logic of the platform, and a cluster of Kitura servers is deployed for resiliency, running in Docker containers on Kubernetes. The Kitura server talks to a database for persistence. Currently, they're using MySQL. IoT devices can communicate with the Kitura REST API using JSON Web Tokens for authorization. They have a variety of IoT SDKs, all open source, supporting a broad range of hardware. The platform has a web front end implemented in Node.js. This includes things like the user portals and the admin interface. Users can also install an iOS or an Android app to quickly see the status of their connected devices and their payment history. Of course, the iOS app is written in Swift. The final piece is the payment processor, which is another Kitura microservice. This handles communicating with various third-party payment providers. Again, there are multiple instances of Kitura running for failover, and they're deployed in Docker containers running on Kubernetes. So, as you can see, this is truly a full-stack Swift solution. Let's take a look at some of the production data from these Swift microservices. Here we're looking at live CPU monitoring from Kitura, collected via Prometheus metrics and visualized using Grafana. You can see that Kitura is using less than 1% CPU. Looks good. And here's a different view. This is from an iOS app they have to monitor the platform. You can see the memory being used by Kitura microservices. It's around 25 megabytes. The Kitura team has worked closely with Banking of Things as they develop this platform, and I'm really grateful to them for letting me show you under the hood today. It's a really great example of a full-stack, end-to-end Swift solution. So that concludes our talk today. If you'd like to try out Emoji Journal and build your own social network in Swift, you can visit ibm.biz/trykitura, and you can get 25% off the book today. We're also giving away a free copy of the book. If you log on to slack.kitura.io and join the Try and Win channel, you'll be entered into our competition, and we'll be choosing the winner at random later today. So join the channel now. Finally, we have a workshop tomorrow where you can get hands-on with Kitura, and it's great to hear that more than 70 of you have signed up already. And of course, there's the IBM booth here, where the team would love to talk to you about server-side Swift. Thanks so much for your attention this morning. Thank you.